Hi everyone, welcome back. In this video we are going to learn about SVD decomposition function. This function is very important for image processing, signal processing, also for data analysis. Of course we are going to focus on image processing side. In image processing we are using this function for image compression, for data compression. Also at the end we are going to make an example with the code part, and in there we are going to see how we are decreasing the size of input image, also how we are compressing them. Okay. And also inside this function there are many complicated linear algebra formulas. Also I'm gonna show you them, but we are not gonna get into the deep of them because they are really complicated. We are just gonna focus on the purpose of this function. Okay, this function stands for Singular Value Decomposition. You see in the name decomposition. What does it mean? Basically you are just giving your input image or input matrix, and at the end it's gonna give you three different kind of matrix. So your input image decomposed into three different matrix. This is the thing you need to know. Also let me show you the formulas, how complicated it is. This is an online calculated, and I just gave an input matrix 3 by 3 and it started to calculate. There are many steps. First step, calculating eigenvalue and eigenvectors, and there are other complicated steps. It continues, and at the end as a result it gives me U, W and VT. In here labeling is different. U is same with the OpenCV side, but this one is equal to W in here, and VT is equal to V in here. This is the thing you need to know. And other thing maybe I can show from here also. These outputs U, W and VT, if you multiply them at the end you are gonna get your input image again. So we at the starting of the code part I'm just gonna show you this one also, how we are first of all decomposing, and after that I'm gonna compose, I'm gonna reverse, so we are gonna get the same input image. These are the fundamental things. Of course we don't need to go to the details of the formulas, but at least you need to know these simple steps before using this function. Okay, let's switch to the code part. In here I have a Lena image. Let's see that one. Okay, this is my simple Lena image, so I'm gonna use this one. First of all, I need to convert this input image into the float type of image, because this function is gonna take float type of image. Okay, this is input image and I'm gonna use my type 32 float. Okay, now I converted my input image. Then I can continue with the creating my decompose matrix, which is gonna be U, W and VT. But okay, after that I can directly call my function, which is SVDecomposing function, and after that I'm gonna give my input image, and after that W first of all, and U and VT. Okay, all is done. Without problem I'm gonna get my output. Also other thing is already started to calculate, but you will see this is taking long time, not yet giving me output. Maybe already 7-8 seconds later it's giving me the output. Why is like that? Because you see in here this is just 3 by 3 matrix and it's making many calculations. Imagine this is not 3 by 3 but my Lena image, by the way, 512 by 512 width and height. So imagine this is huge numbers, huge values inside, so of course it's taking long time. Also you need to consider before using this function, this is taking long time. Okay, so at the end I get my output matrix. So if I try to directly multiply them and to get my output image again, so how was the order in here? U, W and VT, right? U times W times VT. This is gonna give me error, I know that, but also you need to know, so that's why I need to show you the size of these outputs. W dot size, and also I want to see the size of other outputs. So at the end, if I'm gonna get the same input image, it should be also the sizes should be 512 to 512. So I'm expecting all these output matrix should be in the same size of this one, but it's not like that. Let's see the result. Because I'm just gonna reverse it, right? So I need to get these sizes, but let's see the size of the output matrix. Yeah, also it gives me error because of this multiplication. The reason is in here. You see, this is same size with the input, same size with the input, but this is not the same size with the input. So why is like that? Because OpenCV, I don't know, maybe this is just for optimization, but they are giving this in the first row only. So they are not giving these values in the diagonal order, because these matrix, these values, which is 512 value only inside of this W, these should be in the diagonal order, so it will be 512, 512, the other values will be 0, so only diagonal order this should be, but it's giving in this way. So we need to convert this into the diagonal way. There is a very simple function in OpenCV for that, which is a diagonal, and we need to give W, and also to see the result, maybe we can copy paste to here. Now all the output matrix is gonna be the same size with the input image, so there is no error we are gonna get. In here it was giving error in the multiplication of the matrix before. Now all is same and it's not giving error, so we get our output matrix. So output image is equal to the input image now, because we already multiplied. But how the way we know they are same? Easy to understand. Just call the convert scalabs in here, and output image is gonna be then output image I want at the end. So I'm just changing the type, float type to the unsigned char type. So output image is gonna be this one. So with the imshow, I'm gonna see the Lena image now I'm expecting, because we believe they are same. Okay. Yeah, now this is the Lena image, same with the input image. What we did, we decomposed, then we composed again, so we get the same input image. The next thing we need to focus on image compression. Maybe before passing to that step, I just want to write the input image, but I want to write into this images folder, and after that the name of this one maybe input.jpg, and after that the input image is gonna be this one. Similarly, I want to write the output image also in here before imshow, this one and this one. So now I'm expecting the size of these two is gonna be the same sizes. Let's see the result. Okay, it's still calculating. Yeah, now we get input and the output images. You see the sizes are same. Also images should be same. Okay, this is not showing yet. Okay, the sizes are same, so we get the same input and same output at the end. So we reverse just. Okay, now at least we are understanding how this function is working. Now let's switch to the image compression part. For these three output matrix, all is used for different kind of purposes, but for image processing we are just gonna focus on the W part. We are just gonna modify this one also, and at the end we are gonna get the compressed output image. Also, if you not yet watch my DFT DCT functions, you need to watch them, because in that also I'm making kind of image compression. So the similar logic we are gonna use also in here. First of all, we need to define a threshold value, maybe we can call it, it's not wrong, and we can start with the, let's say 512 is gonna be limit, by the way. Let's start with this one, and after that we need to modify only the W part, but with the modified one I don't want to use the same W. Maybe we can create the new one, met W compressed. Okay, this is gonna be equal to, all the values is gonna be equal to zeros, but the type and the size is gonna be same with the W. Okay, now all is done. I'm gonna equal this to 0, smaller than threshold value. After writing this part, I'm gonna explain. Okay, and I'm just gonna equalize this W compressed values into the double, maybe this is CV point and 0 to I is equal to W values. Okay, now it's done. What I'm doing in here, this threshold value is just taking some numbers of the W. The first values, this W, by the way, before taking this one, only has 512 value, which are gonna be diagonal elements. So these values, the first values are the important one. By the way, if you continue to the end, the last part of the elements, the details are decreasing. So the first values are important, the last values are the less important than the first values. So similar logic we are using for the DCT also. We are just gonna ignore some of those values. That's why we are making threshold value in here. So this W compress except until to the threshold value, the others is gonna be ignored and they are gonna be 0 values. So for the first time we are just equalizing all the values. So at the end we are gonna see all the same size we are gonna see again. So nothing is gonna change because they are almost, not almost, but they are totally same to each other because of this value. And maybe we can see also, I don't need the sizes to see anymore. Let's run the code. So now I'm expecting same thing in here. The sizes is gonna be same. Let's see. Okay, you see they have the same sizes because they are the same like before. But if you change this into the 300, now I'm expecting 212 values are ignored. They are 0 now. So I'm expecting less details is gonna come to me now. You see this image seems almost same, but some details are lost. So I'm expecting the size decrease into the 81.5. Also, I don't wanna delete them, overwrite them. So this is 300 before. Now I'm gonna try 150. Let's change this one. So I just decrease the number again. So now I'm expecting the new image is gonna be less than 81 kilobyte. Let's see. You see this is still, maybe you don't understand, but details are lost again, and the size now 77 kilobyte. So I'm gonna make 50. I think now you will see some changes by looking to the image. Now the new one is gonna be less than 77, I'm expecting. Okay, it's 66 kilobyte now. Also now you see the details are lost. Yeah, this is the simple logic how we are compressing image. Of course there are some backend of this function is also doing something, but we are making with huge differences, so we can easily see with the size of image. Okay, what we did, we already learned how this function working. It's decomposing, and we at the beginning we just composed again, we see the same input image. After that we see how we are compressing the images with this SVD decomposition help. The disadvantages of this one, this is taking a long time, but comparing to the DCT and DFT, I can say this is compressing better. There are always trade-off, you see, right? We talk about data loss details, we talk about the sizes. Also now we are talking about the time, right? Time increasing, but is okay, still data is lost, but it's giving me better results, I can say. Yeah. Okay, basically in this video I just wanted to talk about how this is working. I hope it's helpful. See you in the next videos.